We are all here just to prevent soldiers from being killed.
Modern warship design is a complicated business focused primarily on maximizing survivability.
If you have a low signature, if you are not seen by the enemy, then you have a higher probability to survive an attack.
So the big question is, who sees who first? Do the adversaries see our ships first, or do we see the adversaries first? And that's critical for designing missions and saving people's lives. So we're trying to build the tools to predict how well other people can see us and how well we can see other people.
Every surface and system on a warship contributes to its signature, how detectable it is. Sloped surfaces deflect radar energy, while flat vertical surfaces reflect it back. The more heat a ship emits, the easier it is to detect with thermal sensors and heat-seeking weapons. Noise can be reduced through specially shaped propellers and by isolating machinery to reduce vibration. Low magnetic materials help reduce the risk from sea mines. Low-profile designs limit visibility to the eye and optical sensors. What the ship transmits can reveal its position, and the shape of a ship's hull and its propulsion can affect how visible it is. The NATO Science and Technology Organization has hosted a trial in the Arctic for scientists to collect data to help ship designers build less detectable ships. The task group, known as SET-353, have a wide knowledge of ship signatures in the visible and infrared waveband region.
We've been to different locations in warm and humid condition, in dry and cold conditions, but we never had a condition like this. The Arctic is much different to what we've experienced before. And if the weather is changing, and it changes very rapidly here in the Arctic, the signature changes rapidly. So this has to be taken into account when we use ship signature models.
With the ice reducing in the polar area due to the climate change, new shipping routes open up that make it easier for potential aggressors to come into NATO seas. So that's what we try to address with this research trial.
The NATO scientists used a recommissioned motor torpedo boat called the X-Grib. The boat is fitted with 2 diesel engines, with the exhausts positioned at the waterline. The top container on the ship's deck houses a heater to ensure that there is a contrast in the thermal images under these cold conditions. The boat is instrumented with sensors on all surfaces to monitor the temperatures. The scientists analyze the data from the measurements and compare these with the predictions. This allows them to tune their prediction models.
Actually, we have quite a lot of different sub-trials here. So a lot of groups operate infrared and visual band sensor systems to record the signature of a test vessel we have out on the sea in front of different backgrounds, sea background, land background, as well during different atmospheric conditions and with different orientations. On the other hand, we have as well groups that concentrate on characterizing the atmospheric conditions in a detailed way.
Out here in the Arctic, even the quietest movement leaves a trace, one that scientists are learning to read in entirely new ways.
The sea surface is rich in information, and when a naval platform navigates on the sea surface, it disturbs the sea surface, creating multiple phenomenology. One of them is the Kelvin wake, which is the very common wake that we can see. The better we understand how the wakes can be detected and how it can be used, the better we can give guidance on how we can build and improve naval platform signatures.
It's cold. Right now we have a situation where the water is actually warmer than the air. So right now we have water that is 1 or 2 degrees Celsius heating up our hull. That's a change in the signature compared to what we would experience if we're further south.
A lot of the work that we do helps advise future shipbuilding and targeting, largely because we can design things into the platforms that will minimize the platform's detectability by hostile threats.
This research will impact the way we defend our ships against guided missiles of the new generation, and also will impact the way we detect the adversaries earlier, so we have the time to react better.
We're here with 9 other nations. The beauty of this is that not all the nations have a complete suite of cameras and capabilities to collect the data that we would need. Working with our NATO partners allows us to cooperate not just with hardware and equipment, but with technical know-how to share the information and share the knowledge.
Around the Arctic Circle there are 8 nations, and 7 of these nations belong to NATO. So it's very important to work together, to make investigations together on this very interesting area. It will be an area that becomes more and more relevant in the future.
This work will allow us to predict how these platforms will operate in cold environments and how threats will operate in those environments, and it will give confidence to the Navy that they can operate safely in these sorts of waters.